All right, today we're looking at composite limits or limits between two graphs. This is the idea that we have a graph of two different functions and we're finding the limit of some operation between them. So the first one, limit as x approaches 0 of f of x plus g of x. Your first thought is just, okay, I'll do the limit of f as it approaches 0 plus the limit of g as it approaches 0. As we approach 0 for f, it's 2. Oops, there we go. It's 2. Plus, as we approach 0 for g, it's -2. Add them together, end up getting 0. Nothing too crazy. But that becomes a problem when we look at one like b. If we approach -1 on f, it does not exist because left and right. -1 on g does not exist, left and right. So you'd probably think, well, that just does not exist, but that's not the case. It actually does, because we're forgetting the definition of a limit. A limit is defined by the limit from the left being equal to the limit from the right. So let's look at that. Limit as x approaches -1 from the left of f of x plus g of x, and the limit as x approaches -1 from the right of f of x plus g of x. So looking at the left of both of them, left here, that's going to be 1 plus -1, which equals 0. On the right, we have 2 plus -2, which is equal to 0. So the limit doesn't exist, or does exist, and it's equal to 0. Similar process happens when we're looking at something like c, where you're doing multiplication. So nothing too crazy there. We get a little bit weirder when we look at division. Limit as x approaches 2 from the left of f of x over g of x, so d right here. So let's look at that. If we approach 2 from the left for f, we're approaching +1. So that means this is +1 on top there. If we approach 2 from the left on g of x, it's approaching 0. So you're probably looking at yourself like, oh, that's undefined, it does not exist. But as I said before, if it does not exist, we need to make sure to identify if it's infinity or not. Because if it is, I'm going to ask you which infinity it's going to. So let's look at this more specifically. We're not just approaching 0 here. So that's 0. We're not just approaching 0. We're approaching much smaller and smaller numbers and then getting to 0. So we're approaching -0.5. Then -0.1, then -0.01, -0.001. So we get negative really small numbers. And we've talked about this before. When a denominator gets really, really small, then that means the whole number gets really, really big. So what this really is 1 divided by a negative really small number, which means we're going to be going to a negative really big number, or negative infinity. All right, you can see the same thing in the next 3 problems. I'm not going to work through each one because it's just more of the same concept, but you can work it on your own. Moving into now what we call composite limits. These are ones where it's a function inside of another function, and this requires you to really change how you're thinking. Just like when we do composite functions for function values, so like f of g of 3, where you plug it into g and then plug your answer into f, we're going to do something very similar here. We're going to take the limit and we're going to look at the limit of g first. So the limit as x approaches 1 from the right of g. As x approaches 1 from the right of g, we're approaching -1. But we can't just look at what we're approaching, we have to look at what we're approaching from. We're approaching -1 from numbers bigger than -1. So that means this is approaching -1 from bigger values. So when we expand out to f, we're going to approach the x value of -1 from bigger values. Limit as x approaches -1 from bigger values of f of x. And we're going to find this limit. So we'll approach -1 from bigger values, and that's equal to 2. Similar thing happens here in I, but I is a little bit trickier. If we look at I, when we look at G as we approach x equals 1 from the left, approaching x equals 1 from the left, we get -2, but it's not approaching from higher or lower. So we don't really know what it's going to do, but let's see what happens. So this is approaching 2, which means we're going to use that for our limit for f, limit as x approaches 2, and we don't really know what side yet, but let's see what f is doing. Maybe we won't need it. So as we approach, sorry, not +2, -2, as we approach -2 in f, oh, that's good. Doesn't matter what side we approach from, it's still going to be approaching 0. These problems where it doesn't approach from bigger or smaller can only be done if it approaches the same number on both sides. If it doesn't, I wouldn't even give you one like this because it can't be done. So that means this limit is equal to 0. You can try J on your own to see if you can figure it out. If not, then let me know. Aside from that, you have your worksheet. Let me know if you have any questions.